All right, so here we have a whole lot of examples of problems that can be solved with our kinematic equations. Here are kinematic equations. We've gone over these in class. They are different ways to find our information: change in position, time, initial velocity, final velocity, and acceleration. We've got these equations from the graphs, and I'm sorry for the typo in here. They don't need to be repeated, so we can ignore sort of the second set of things. Now, as we go through these questions, we are going to identify our givens, find our unknowns, pick an equation, substitute, and solve. We're going to use the guess equation, we're going to use the guess method to solve each one of these word problems. Now, these are tough, so we're also going to do what we've been doing, which is box givens and circle unknowns. This is important. It's going to help as you go through this just to find our things. So, number one, a rabbit starts from rest and accelerates at a constant rate of 2.5 meters per second squared. What is the velocity of the rabbit after it has traveled 8 meters? So, it starts from rest, so that's our initial velocity. We have an acceleration of 2.5 meters per second squared. We want to know, sorry about that, we want to know the final velocity. What is? So we're going to circle that. And then after it has traveled 8 meters. So the delta x is 8 meters. So, for our givens, we know that the initial velocity is 0 because it says from rest. We have an acceleration of 2.5 meters per second squared, and we travel a displacement of 8 meters. What we want, our unknown, is the final velocity. Now here's how I like going through these problems. We have this stuff. We have 4 pieces of information. What I want to do is find an equation that has those 4 pieces of information in it. This one has time, so it's not what I want. This one also has time, so it's not what I want. But this last one here, that has final velocity, initial velocity, acceleration, and displacement. This is the one I'm going to use because it has all of the pieces that I'm given. So for the equation that I choose, we're going to say that the final velocity squared is equal to the initial velocity squared plus 2a delta x. Now, I have most of that stuff, so I'm going to plug in that stuff. So the final velocity squared is the initial velocity squared, so 0 squared plus 2 times 2.5 times 8. So that goes away, and the final velocity squared is equal to 40. But I'm not done. That's the final velocity squared. So if I want the final velocity, it's going to be the square root of 40. So that final velocity comes out to be 6.32 meters per second. That's how we're going to use the guess method. That's all these are. Let's go through it again. A drag racer accelerates from rest to its top speed of 88 meters per second in 8 seconds. What distance does the drag racer cover? So from rest tells me that the initial velocity is 0. The final velocity, the top speed, is 88 meters per second, and it takes 8 seconds. So the things that I don't know are the acceleration and the displacement. So here's the deal. If you don't know the acceleration, step 1 is find the acceleration. Step 2 after finding the acceleration will be to find step 2 after the acceleration will be to find the displacement. So, starting at step 1, find the acceleration. I want an equation that's going to include initial velocity, final velocity, time, and acceleration. If you look up there, that's the first one. Final velocity equals initial velocity plus acceleration times time. The other way we could look at that, well, you know what, we'll just do that. Final velocity is initial velocity plus acceleration times time. So we plug everything in. 88 is equal to 0 plus acceleration, which we don't know, times the time of 8 seconds. So 88 equals 8a. Divide both sides by 8, and we see that the acceleration comes out to be 11 meters per second squared. Now we can move on to step 2, find delta x. Well, we have everything, so we're just going to pick the equation that has delta x in it. So delta x is equal to v0t plus 1/2 at squared. We're going to plug everything in there. So delta x is equal to 0 times 11, 0 times 8 plus 1/2 times 11 times 8 squared. So the delta x, that part goes away because it's 0 times 8. Comes out to be 352 meters. Let's do the next one. Dave starts at rest 22 meters away from a flagpole. He runs towards it and reaches it in 8 seconds. What is his acceleration? So, for my givens, we start off at rest, so the initial velocity is 0. The distance Dave travels is going to be 22 meters. He's going to do all of that in a time of 8 seconds, and what we want is the acceleration. So if we look at all of this, those things are in this equation. Delta x equals v0t, v initial times time, plus 1/2 acceleration times time squared. So we're going to plug everything into this, and we're going to find the acceleration. So delta x is 22 meters is equal to 0 times 8 seconds plus 1/2 times the acceleration times 8 seconds squared. So the 0 times 8 seconds part goes completely away. I have 22 is equal to 1/2 times 8 squared times a. So 22 is equal to 1/2 times 64, 32 times the acceleration. Divide both sides by 32. And the acceleration comes out to be 0.69 meters per second squared. The toughest part about this, in my opinion, is picking the equation. Everything else is stuff that we've done. All right, we've got a little typo. All right, so we have Carol who's rolling a ball down a ramp. The ramp is 2.2 meters long, and she knows the acceleration is 2.8 meters per second squared. What we want to know is how long will it take the ball to reach the end of the ramp. So for my given information, I know that the ball is going to travel 2.2 meters. I know that the acceleration is 2.8 meters per second squared, and my unknown is time, how long. But there's another one here. when Carol rolls the ball down the ramp, Carol's going to start it at rest. So here, one of the things that it's telling me, one of the things that we have to imply, is that the initial velocity is 0 meters per second. This is a tough point because it doesn't tell us that. We have to figure it out. So we know that she's going to start off at rest. That doesn't say it in the problem, but we can go ahead and infer that it does start off at rest. Now, the equation that we're going to use has delta x, acceleration, initial velocity, and time in it. That equation is delta x equals initial velocity times time plus 1/2 acceleration times time squared. Now, since the initial velocity is 0, I can cross this term out. And that tells me that delta x is equal to 1/2 at squared. So I'm going to go ahead and plug in my numbers. So delta x, 2.2 meters, is equal to 1/2 times the acceleration of 2.8 times the time squared. So 2.2 is equal to 1.4 times time squared. We'll divide both sides by 1.4. So we'll just kind of continue up here. Time squared is equal to 2.2 over 1.4, which is 1.57. And then in order to find time, I'm going to square root both sides. So time is equal to the square root of 1.57, or time comes out to be 1.25 seconds. The math was a little tricky on that one. It was really far inside of it. So, next one. A car traveling down the highway has an initial velocity of 35 meters per second. It slows down to 25 meters per second in 100 meters. What was the acceleration of the car? So, my givens, we have an initial velocity of 35 meters per second. We have a final velocity of 25 meters per second. And that takes place in a distance of 100 meters. And my unknown is the acceleration. Again, looking at all of this stuff, I want the equation that has all those things in it. So my equation is going to be v final squared is equal to v initial squared plus 2a delta x. So, next thing to do is plug in all of our stuff. V final is 35 squared is equal to 25 squared plus 2 times the acceleration that we don't know times delta x of 100 meters. Best thing to do is go ahead and calculate everything out. So 35 squared is 1225 is equal to 625 plus 200 times the acceleration. So the first thing that we're going to do is subtract 625 from both sides. It cancels out on this side. And what that gives me, if you don't mind, we'll go over it. So 1225 minus 625, that gives me 600 on this side is equal to 200 times the acceleration. We'll divide both sides by 200, and the acceleration comes out to be 3 meters per second squared. Alright, last one on this sheet. An airplane being launched from the deck of an aircraft carrier accelerates from rest to a velocity of 122 meters per second when it's launched. The deck of the carrier is 158 meters long. What acceleration do we need to have? Alright, this is going to be the same kind of thing. My givens My initial velocity, since we're going from rest, is 0 meters per second. My final velocity is 122 meters per second. My displacement is 158 meters. And my unknown is the acceleration. So what we need to do is find the equation that has all of those things in it. So for my equation, same one, v final squared is equal to v initial squared plus 2a delta x. So looking at this, we're going to plug in our numbers. 122 squared is equal to 0 squared plus 2a times our delta x of 158. So when we multiply that out, we get 14884 is equal to, so that 0 thing goes away, don't even need to write it down, and then 2 times 158, I want to kind of put all that together, is 316 times the acceleration. So I want to solve for the acceleration. We're going to divide both sides by 316. So 316 divided by the acceleration comes out to be, so 14884 divided by 316 comes out to be 47.1 meters per second squared.